Expanding out section 14.4, when we talk about area and law of signs has some issues in it. So in this case, we're going to talk about the ambiguous case. Okay. Once again, a lot of our theorems that we work with deal with those congruency theorems we had in geometry class. We talked about side, side, side congruency. We talked about angle, side, angle, or angle, angle, side congruencies, or side, angle, side congruencies. Those all had great issues. One of the problems we had was when we had angle, side, side. We didn't have congruency. We had issues with this. And one of the main reasons why on here is if we were to look at this obtuse triangle given right here, if I were to extend this line out right here and then draw out this same side over here. So what we see is that this side I swung over here, and basically I made what was once this right here look like this here, where this is congruent and this right here. These two triangles are not the same. So when we use law of signs, there's always something that we got to visually kind of either work with or check to what's going on. Now once again, if we know angle, side, angle, 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 side, basically if we know two angles, okay, we don't need to check. Our answer is valid. If we know side, 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 we're going to have to use law of cosines, which we'll cover in a later section here. If we talk about side, angle, side, once again, this will be law of cosines. Okay, so when we start talking about this within here, we have some issues with this. Even though we have that side and angle opposite right here, because of the other part we're up to, we can't necessarily tell what precisely is going on. So how do we work with these problems? How do we do this? Well, I'm looking on page 935 right now. Okay, so what we're going to do is we're going to look at problem set number 1. Okay, so number 1 here, it gives us a description. Okay, now granted, we do not have a visual triangle drawn for us. So when we have a visual description, we always have to be careful of what we can consider is actually happening. They tell us that we have the measure of angle A equals 62 degrees. A is 30 in length. B is 32 in length. Okay, so if we were to draw kind of what's happening overall here, I could say this is A, here's my 62 degrees, here's my 30. It then says, okay, so if I let, let's see here, B be right here, so B is over here, and then this would be side C. It's asking us to find all our other counterparts to this. So what we would need to start with is we would need to first have to find our missing side. I'm sorry, side B here would be 32. So it's not missing, it's there, it just was hiding on me. Silly paper and invisible ink. So we have that 32 for a side length base, so we want to kind of revert this back to that angle. So we would talk about that sine of B over 32 would equal sine of 62 degrees over 30. From here we would solve for angle B. In solving for angle B, we would have, I'm just going to go, the measure of angle B would equal the sine inverse, because I'm going to take 32, multiply it over, then take that sine inverse of everything. So I have 32 times sine of 62 degrees over 30. When I type this into my calculator, I'll find my calculator here, we see that we have 2 times sine of 62 degrees over 30 we see that we get 70.35. So I'm just going to go 70.4 degrees. So I see the measure of angle B is 70.4 degrees. Now, what we do to hypothesize or try to figure out what our other angle would be is we would treat it as, what if this was the obtuse part of it? So we would take 180, let me change my color here so you can see that this is kind of off on the side. We take 180 minus 70.4. So if I take 180 minus 70.4, I would see that I could also have 109.6 degrees. Now, what we would want to check in here to see if this is a possibility is, once again, you see I took this right here, that 109.6, we would want to add in what our known angle is. So if I add in this, notice I am still under 180 degrees. So because I'm 180 degrees, I have these two possible answers. So now if I go through and I figure out what would be my other parts, okay? So if I'm working on my first triangle possibility here, measure of angle C. So to find measure of angle C here, we would take 180 minus that 62 minus that 70.4, and we would see we would have 47.6 degrees. Okay. Now we'd want to find side C. So what I would, or the side C here. So I would take C over sine of 47.6 equals 30 over sine of 62 degrees. Okay, once again, I'm going to go back to my original known one right here, where I have that 30 and the 62 degrees. Once again, because B, I could use the side B of 32 and then sine of 70.4, but that leaves in a possible rounding error. We want to try to avoid that as much as possible. Okay, so when I calculate this out, we would see that C would equal 30 times sine of 47.6 over sine of 62 degrees, which means C equals, once again, I'm organizing my one triangle here, and then I'll come and organize my second triangle over here. So if we type this into our calculator, we would get, let's see here, we would have 30 times sine of 47.6 degrees over sine of 62 degrees. We get 25.1. Okay, so we see that side length would be 25.1 for side C. Now if I come over here and switch over then to my orange marker, you could leave it as is. You don't necessarily need two different colors for your answers, but just trying to keep it as simplified as possible to show you that there's a breakup of two possible ones here. What we would do now is we would take that 180 minus 62 minus 109.6, and we would see that we would have 8.4 degrees left. Okay, so if this was an obtuse triangle, we have a very small angle left in here. But now if we wanted to find side C to this, once again we would come and state that, well, C over sine of 8.4 degrees equals 30 over sine of 62 degrees, in which then C equals 30 times sine of 8.4 degrees over sine of 62 degrees. So if we type this into our calculator, we have 30 times sine of 8.4 over sine of 62. We get 4.96. So that 6 is going to round the 9 up, so we will go 5.0 then for that side length. So do realize that this ambiguous case really has some issues, especially if we know our angle side that's on here. We have to check because there is always a possibility that there's two answers. Does it mean that there is always two answers? No. There's not always two answers, but it's something that we always have to be well aware of and why it happens and where it's going to happen.